Hello, hi everyone. I'm audible. Hello, I'm audible. Okay, okay. Thank you. Just wait 1 2 more minutes. If anyone else is there, so good. So he could join. Hi, let's get started with today's session. So today's session is real-time file I/O, the TAIL-F challenge. This is the fourth session of the our industrial level Python development navigate. So today we are gonna see what is real-time file IO, the TAIL-F challenge. So before going here, why we are here, we will see what is actually file IO. So file IO is nothing but just a file IO input output file. Input is reading data from a file and output is writing data to a file. Like reading a diary input and writing in your diary is output. We can give the examples. Why real time? Why it's real time? So sometimes files are constantly changing. Examples, for example, chat logs are updating, system logs growing as things happen, application writing, states updates. So we're gonna see today what it is actually the real time FO and how TLF challenge plays its role. And before going further, what is TLF? TLF is a concept. So it's a well, we can simply say it is, for example, if you type TLF file name, so it will show me the latest lines and keep watching the file forever. So it's a real life analogy, like watching a WhatsApp chat where new messages appear without refreshing. That is the TLF. Without refreshing, the things would coming up. For example, what Python needs to do is Python equivalent to tailf. It is open the file, jump to the end, watch for new lines, or print them whenever they appear. So whenever you give these commands, you don't have to do anything after that. So it will do the real time. In real time, it will keep updating the things. So today we'll see why we are here. So today we are learning how to make our programs react to change as they happen. The classic example is watching a log file for new entries. As I told, like log files, you can give the commands, so then it will keep on updating by its own. So in layman view, we can, for example, I can give you the example of imagine a live news sticker on TV. You don't get the entire day's news reprinted every 10 seconds. So you just need the new headline as it is added. That's what tailf does. It follows a file, shows you only the new lines that get added to the end. It keeps on updating every constantly without being giving a continuous input from here, the commands. So we want our Python program to be news ticker, instantly showing new log entries. like for example, error database down without rereading the whole file. So in tech view, we can say this is all about real-time data injection and monitoring. For example, standard file input, output, input, you can open the file or dot read, yeah, close the file is a one-time snapshot. So we need a persistent script that monitors a file from appends. So we can add anything to that new file, so it will keep on going. For example, use cases, log monitoring. So watching server.log for error or fatal strings to trigger alerts, or data injection in a CSV file or JSON where sensor like a thermometer is constantly writing new data. So that is the part one of this is the magic bookmark pointers. First, we will understand this code, then we will at the end we will run it and we will see in how actually it goes. Part one is the magical bookmark, this file pointers. So to avoid reading the whole file, we need to know where we left off. Python does this using a file pointer or cursor. So for example, imagine you are reading a book. When you read a book, you don't finish it on one sting. You stop somewhere, and what do? You keep the bookmark. So next time you open the book, for example, anytime you are reading a novel or something, so you completed 5, 10 pages or half of the book, so you'll keep a bookmark there. So when you next time when you open the book, you know exactly where to continue. Or if you don't keep the bookmark or anything, you kept on reading and suddenly you got some work, you just closed the book and left off. So when you came back, when you start reading again and you don't know where I actually left her, so you have to look line by line or page by page where exactly I was. So to make it easy, you keep a bookmark there. That's the thing. So files also need a bookmark. Why Python reads a file, it also needs to remember where did I read up to, where should I continue from next. That special bookmark is called file pointer. So what is exactly pointer? In simple words, we can say it's like a marker that tells Python you are currently at this position in the file. So it does not store text. It only stores the position like start of file, middle of the file, end of the file. We can give the examples like line one, you will hear line or line two or line three, so on, blah blah. So when Python starts reading, pointer starts at the top, line one. So for example, from here you start reading, or from here, the pointer starts at the top line one. So after reading line one, pointer moves to line two. So it keeps on moving. You keep your reading going on, the pointer keeps on moving. So after line two, it will go to the line three, so on to the line end. That's exactly like your bookmark moving forward as you read. So why is this important for real-time reading? Because when you want to do the tail F, watch new lines appear, you must first jump our pointer to the end of the file, just like you would skip to the last page if you want to read new messages. To jump the pointer, Python uses this seek, f dot seek, where it exactly jumps to the particular line. So, for example, meaning zero Python f dot seek, and within the brackets 0 comma 2. For example, move 0 characters from the end of the file. 2 represents from the end of the file. So we are saying move the bookmark to the end of the file. So Lemon says, imagine a giant paper scroll. When you open it, your finger, the pointer at the beginning position. As you read, your finger moves. So if you want to jump to the end, you seek the end. You can even ask, why is my finger right now? So in tech language, we can say the file handle maintains the pointer to the byte offset. we can control this pointer with two key methods, and the methods are here. For example, f is our file handle. This is a file handle, so it will open sample text. This is a file name, sample text, and uh, this is a pointer. So f tell where is my finger returns the current byte position. So print f dot tell is will give us the output at the beginning. So app seek out offset, where move the finger offset is now how many bytes to move, and whence is where to move from. 0 is represents from the start, that's default, and 1 from the current position, 2 from the end of the file. Let's read, for example, 10 bytes. So f dot read 10 tells us print f to tell, so it will give the output as 10. So let's jump to the end of the file. This is a key to TLF. F dot seek move 0 bytes from the end, whence is equal to 2. So print app dot tell output total size of the file in bytes. It will close. So what it does actually, so bookmark in a book, for example, is a file pointer there. So this lets Python wait for the new lines, not to reread old ones. So simple one line definition I can tell is a file pointer is a bookmark that tells Python where it is in a file. And part two is the simple way pooling. So we can understand this program. So this is like you open the book called sample.txt. This is a book. Open, you call it. So R means read mode. It will read the book, and F is like your hand holding the book. F is your hand holding the book, and read is a read mode. You want to read it, and it also finger inside the book file pointer. This is a file pointer. So when you tell f dot tell, it means tell me where your finger is right now. It means where your finger is current. Finger at This is finger at r dot run. Finger is at position 0, the very beginning. So output will be 0 here. So because it's a default point in this position. So this here step 3 tells f dot read 10. That means Python reads 10 characters. Your finger moves forward by 10. Example, before reading finger at position 0, it was here at position 0. Now it is at position 10. So output will be 10. Then the setup po is jump to the end of the file, seek 02, and this is the most important line of understanding TLF. The seek offset. This is actually f dot seek offset. Offset 0 is the offset, comma whence means move the finger to the new position. Offset 0, move 0 character, and whence is equal to start the end of the file. So you are saying put my finger at the end of the book, and we can close this. So to read new lines added to the file, we must jump to the end, first using C comma to then watch the new content. So this is all about the magic bookmark file pointers, part one. This part two is the simple way pooling. Simple way pooling is nothing but why we need it for the real time. It's nothing but like imagine, for example, you are waiting for a message on WhatsApp, but instead of app notifying you, you open WhatsApp, check if someone sent a message. No message, you close the WhatsApp, wait a little, open again, check again. You keep checking every single second. This behavior is called pooling. So every time, instead of refreshing, the message comes by its own by default. So you open every time WhatsApp, check it is there, It's not there, just close application. So pooling is repeatedly checking if something new has happened. So continuously opening the WhatsApp and checking whether new messages are coming or not. That's we call it as pooling. So repeatedly checking if something new has happened. Pooling in file reading is when you want to follow a file like tailf. So when you want to follow this file keeps getting new lines. Python needs to keep checking, so it cannot read only once. So it uses a loop to check again and again. Pooling is basically, hey file, for example, hey file, do you do you have something new? No, okay, I will come back later. So until and unless it did not find something new, it will keep on going in the loop. So uh, in see, our first attempt will be pooling loop. We will open the file, jump to the end, and then keep asking, is there anything new? Is there anything new? If there is not, close, go back to the loop. So layman, this is like a little kid on the road trip. Are we are we there yet? Are we there yet? It works, but it's annoying and wastes energy. We call this as busy wait loop. Obviously, if there isn't a feature in the WhatsApp, so keep you every time you to check a new message, you have to open a WhatsApp to check every time, is it there. If there isn't any notifications or this messages aren't coming in the background, so you have every time you have to refresh. This becomes, at a point it becomes annoying, it shouldn't be there. So the method involves an infinite loop that repeatedly calls f read line. This is a CPU instance where f dot read line returns an empty string. So we can time dot sleep for a brief moment to yield control and avoid spinning the CPU at 100%. So this is the flow chart. For example, this pooling logic flow is, it starts, open the file, what I already said, you start your phone, you unlock your phone, open the WhatsApp, check message, or message there, no, close the WhatsApp. After few seconds or few minutes, you open again WhatsApp, check there. So that's what it says, start, and it open file. Example, server log is a file, it opens it. Seek to the end of the file. This is a what we already uh, read in this file pointers. So this is a seek where it moves to the end of this file and keep on finding these things. So seek to, then it goes to the start infinite loop. It goes on the loop until try to read a new file, and if the new file is got a new line, so then it reads. If yes, print the line. If no, sleep for 0.1 second, and you can give the timer wide soon to prevent CPU 100% CPU. So then after a few seconds, you can give your uh, program the timer here. So after a few seconds, it will go to the again to the loop, check for the new message. If it's there, read it, return to the start of the loop. So it will go again and again this. So this is called polling. The interaction, let's do it live. For example, you will need two terminals, command prompt open at the same time to see the work. I will provide you the two files, right? Log writer and log vector.py. So for example, these are the two files. For example, how to make sure you have this. Wait, let me check this. Okay, so what we studied in the pool is like the file kept getting new lines. Python needs to check these. So uh, when you go for the this pooling, so it saves our time. So for example, when you give the timer of 5 seconds or 10 seconds, so nothing is new there, I will wait for 5 seconds, then it goes again to there. So it saves reading too fast. It saves our you 100% CPU and checking every microsecond. It's same as you taking a break from checking WhatsApp again. So why pooling is called a simple way? Because it's easy to understand, easy to implement, and works everywhere. So perfect for beginner level tailor. But it has a small drawback. So Small drawback, it keeps asking, is there something new, again and again? And if nothing is happening, the part is for context. So it will go again and again to the loop. So pooling means repeatedly checking, as I told, for new data at regular intervals. I will show you the this. I will share the terminal link with you. I will show. So is it visible? VS link. Okay. So what this log watcher is? This is a script. So it pretends to be a server application that is slowly adding new files to the log file. So you can run it in the terminal direct, and or you can run it in the VS Code also. So we'll try to run it. See, it tells, see here, file name to write to users python log dot py. It keeps on here. For example, user admin logged in at this uh, address, IP address, and starting background job as cache clear. Disk space was this. Background job was cache clear completed, and error if it failed to connect to the payment gateway. So these are the log messages. Connection to the Stripe successfully. User Bob created the new order. So this is a write to file. So opens a file. It opens a file in append mode and writes new lines to it one by one. So this print file does start log writer, and it will add the new message to it. File names add bad. So we can open the file name in append mode. So if file does not exist, it creates it. If the file does exist, it automatically puts the file pointer or bookmark at the end. So read, write, new data. This will open the file name is, and we will keep on looping this. So for message, for example, this is just a example. So it will give the time. It will print the like this. It will when message will be there, it will print the time with it also. When does it creates? So date stamp will be in this format, and it will keep on adding this appending. We does the file, whatever the new messages are there, it will keep on printing. It will write to the output file. Appending is whatever the new message is coming up, it will add to the lines. So the loop will continue going on until it finds a new message. So here it will keep on looping until new messages are found, and it will append the message is whatever you will put inside the message, so that message will come on, and or by default the messages. So this f dot write log line will be the new message that will be right into the output file. So coming back to our this page. So type then we have the part 3 is the industry way event driven. So what is event driven? In simple words, we can say, for example, we can start with a real life analogy. In part two, polling, as you check WhatsApp messages like open, check, wait, check again, wait, check again. This wastes your energy, right? And it wastes time also. But WhatsApp actually works like this. You get a notification when a new message arrives. You don't have to check every time, going again and again, open your WhatsApp and check again and again. So you don't need to keep checking. This is called event driving. Event driven is it does nothing until an event happens. So then responds immediately. Obviously, your notification tune won't ring until a new notification or message came. So it keeps quiet. Your WhatsApp will be there, but it keeps quiet until a new message arrives. When a new text comes, so the pop-up sound or the notification sound will come. So that is event driven. So how industry system monitor files? For example, instead of checking the file every second, the computer waits for a signal from the operating system. The OS literally says, hey, your file just changed, and Python reacts instantly. So whenever a new file comes or changes, so it instantly changes. So Python reacts to this. What are the benefits of this? This is a faster, this is more efficient. Obviously, it's faster. We don't have to waste our energy by checking again and again. This is faster and it's more efficient. It saves our time by going checking again and again, waiting, checking. So it uses less CPU. It uses only that time when there is a thing. So it's an industry standard for monitoring logs, servers, and applications. So simple definition we can give. Event driven means you respond only when something happens. You don't keep checking. So you are somewhere, your phone is in your pocket, and you are doing something, or you don't need your phone right now. But when your phone rings, so you take your phone from the pocket, then picks. So that's event driving. You only respond when something happens, or when you actually need the phone, when there is a notification or pop-up is there. So you are now curious to check what is there. So that's called event driven. Event driven means you respond only when something happens. So it saves our time. You don't keep on checking again and again. It doesn't waste your time. It is more efficient. So what generates an event and when it is generated? A file is written to, and when a new file is written to, so it generates an event. A new line appears and it generates an event. Or there are only 4 files, now there are 5 files. And so a file grows in size, though there is an event driven. The operating system sends a file change event. So when the program reacts, for example, I will show you the simple observation of this. So first we will check what it is, how it is related to this, and how layman tells about layman's definition about this. So the pooling method works, but is inefficient. Our script is always running and always asking anything new, burning CPU. We already read that above. It's a older method, and it uh, burns CPU. It is slow. It keeps on. We have to keep on checking. So lemon, instead of where we are yet, when lemon give the example of that kid, he's in the car, he asking, are we there yet, are we there yet? So we tell the operating system, driver, hey, wake up. When you get the next tea, you can go to sleep, read a book, or waste no energy. The driver will just tap you on the shoulder when it's time. This is an event. So in tech language, we use an event-driven approach. We register a watcher with the operating system file notification API like Notify on Linux, FS events on Mac OS. Our script then goes to the sleep, zero CPU usage. The OS itself will wake up our script and call a specific function, a callback function, only when the file is actually modified. The industry standard library for this in Python is Watchdog. So you need it to install. You can install it through the pip if you have already pip installed in your. So you can uh, install Watchdog through your pip. So this is a more advanced script. It's what I would actually use in production environment. So this imports watchdogs, observers, and it imports time as well. So what this um, program does, it first we define our event handler. This is the object that the OS will tap on the shoulder. We tell it what to do when an event happens. So this log handler, file system handler, we only care about on modified event. So this function will be called by watchdog. When a new file we are watching changes, so it modifies. This is a modifier. So we define modified self event. So event dot src path is the file path that changed, and event dot src is a server log. And this is a message actually. What you want to put in, it's up to you. Like whenever the new path changed or an event creates, so it will give you the alert message. So, for example, in real map app, you would open the file, the new line app, the logic is more complex, which is why pooling is easier to start with. So this is the main setup code. So what this code does, it creates the observer object. This is the process that listens to the OS. Observer, this thing, it is the process that listens to the OS. We then tell the observer watch path, and when something happens, it creates an event. So this is where it creates events. So when we start the observer thread, it start listening continuous. So this is just a loop to keep our main script alive. The observer is an separate thread. Our main thread can just sleep using 0% CPU. Let me show you the code here. Example. So we use the file system event handler here. File system, yeah, this file system event handler. So this is like a security guard watching your file. This is security guard watching your file. On modified, this on modified is a the function runs when life changes, like when file changes, like the file was updated, go read the new line. And the observer is like a CCTV camera, constantly watching the folder. And sleep, we use the sleep here. Event handler print dot sleep is like it will keep on going, so no need for this. So it will say if did the file change. If it is no, and it will go over and over again. They wait for the notification. So tool does what this code does, so it first we imports these files, and time is it tells us a pause, sleep. Observer is, I told already, it is a security guard watching the folder. And file system event handler is a person who reacts when something happens. So we create a class mylog handler, file system handler. So we are creating a special helper that will react when something changes in file. Think of it like this. For example, the OS uh, taps the handler on the shoulder. Hey, something changed. The handler replies, okay, I know what to do now. Then it create reacting to file changes. That is define modified, this thing, define modifying self event. The function runs automatically when a file is modified. You don't call it yours. You don't call it yourself. The OS calls it through watchdog. Watchdog we already import, so it does it by own. So inside the function, if event, this thing, this is a main function. So if event dot src path, so file will change. If the file that changed is server.log, print a warning. It will print this error message or something. Simple analogy. You tell the security guard, if something touches the file, this file, notify me. So what could happen in the real apps is, in the log monitor, you would open the log file, go to the last position, read the new lines, and display them in real time. But for teaching a simple message is perfect. So main, for example, this event handler dot my log handler is this creates you the reaction object, the one that prints alert when something, when server.log changes, anything change in the log, it creates a reaction object. Observer creates the observer, the security guard thing. This creates a process whose job is keep your eyes on the folder and report changing. And the handler observer dot schedule handler path recursive is equal to false. Observer looks for this file path. If anything changes, tells event handler recursive do not watch inside subfolders. And then this observer dot start is equal to it start watching. The guard now begins watching. The program prints a message, so we can now it's working. While true, time dot sleep, sleep is this loop is not doing the checking. The observer does in other thread, so it keeps the program alive. Why this loop exists? To prevent the program from exiting. So simple analogy, we can, the main program is just sitting and waiting using almost zero CPU. Stop watching when we, like, I will give you the example. I will show you how it works. Example dot py. Is the screen visible? Reactive with yes, no in the chat or something. Is it visible? Yes, okay. So it says here, okay, I will. So let us run this code again. So it works now. Just kill this. Can give this simple code example. Let's check this again. See, it runs. So it will keep on, like it will, like I told, the security guard will watch the files continuously until some changes are there in the modified. On modified, we use the term on modified. If until the changes are there, the file will uh, keep on updating them. It will go to the new line. And observer is like a CCTV camera constantly watching folders. So until the new things are there in the file, changes are there, so it will keep on looking into the loop until new changes are there. When new changes are, it will pop up and modified you. So coming back to the this thing. So what it actually does, this part 3 of the event driven, so it the pooling method is like a kid, like I already told, it eliminates the pooling method that we had in the first part. This the pooling part, it eliminates the use of the pooling part, and it uses this as, see, so that wastes energy and attention. So instead of that, the event driven method is like telling the driver, when we reach, wake me that up. So technical meaning, like it will be with pooling, your program keeps on checking again and again. With event driving, your program slips. With operating system itself wakes up your program only when the file changes. So there are different file watchers, and so in different OSs use different systems for these. For example, Linux use iNotify, and Mac OS FS events, and Windows has built-in file watchers. So, but I don't need to know that. So Python gives us a simple library called Watchdog that handles everything. That's what was here, this Watchdog. So you can install it using pip install Watchdog, and it will give you the line-by-line explanation. Like this code also, for example, the observer listens for file changes and all that. So now we read all the three, what is there in the real-time file IOs. Though there were three parts. Part one was the magic bookmark. So it was that where we kept the bookmarks. As I give you the example of the book, you are reading a book. To avoid get reading the same page again, you kept the bookmark, so it will be easy for you to position to start to read from that position again. And that the same thing we in the Python does in the it the file handle maintains a pointer by byte offset, so we can control this file with two key methods. So then the simple way pooling comes up. So what is that? It we already uh, heard that pooling, what pooling does, will keep open the file, jump to the end, and keep asking keep looking for the new things or new files to the file until a new change or this new file comes up. It will keep on asking, going there, checking again and again. Giving an example of WhatsApp, you going again and again there and checking. So then, to eliminate the use of pooling and to save the time, we go to the event driven. Event driven is a uh, it eliminates the this pooling method, which is inefficient. So instead of saying again and again or checking again and again, you can directly take out your phone when a new notification pop-up comes out. So that's the event driven approach. In that, we use a watchdog that continuously, that is a library that is used to mm, continuous monitor your program system and all that. So that's, I guess, all about today's session. So we cover three parts here. That is magic bookmark, that's the file pointers, pooling, the simple way pooling, and third one is the industry way event driving. So if you guys have any questions, you can ask it here. So we can open the panel for next for 5 minutes for the questioning Q&A session. If you guys have any questions, you can ask. See, in simple words, the two main ways to follow a file now. Pooling, the simple way. It's easy to write, but wastes a CPU. As I given, it's an time taking and it's exhausting. And event driven is that's an industry way. It uses the watchdog, which is very efficient. For example, the examples already gave you. So if you guys have any questions, you can ask. No, it's until your program is going on, you can keep on, like, you don't have to keep manually keep on checking everything when you install the watchdog. So it keeps on your program for, like, at how much time your program is going on, the watchdog will keep on checking. So I give you the example of this. uh, Whatever inside happens in the this WhatsApp. So watchdog is there in the WhatsApp program, for example. So until the new thing doesn't comes up, it doesn't pops, the new notification tone doesn't comes up. When there is a new thing there, the new file comes, the watchdog will be activated and it gives you a message. So that is the work of the watchdog. It's not like you have to make it run 24. It's you are running a program, you are doing any task, you are running a program. So in that, if new files are there, automatically updating, it will. Yeah, we will start working on that once we are just covering the basics now right now. So we will catch up the products with it. There is everything. I guess you guys have already saw the syllabus. So when we will reach the projects, you guys will get to know. You will be given like you will be taught everything how to do that. Wait for the session when the projects will be there. It will be soon. Like once we clear the things that are necessary for the project. So after that we can start working on the project. Chalo, then it's I guess all for today. Bid you a goodbye. See you in the next session. Till then, take care. Bye bye. You can leave the meeting now. Thank you. Thank you so much, guys.